Hello everyone and welcome to today's video on volumes of rectangles and prisms and cylinders, and this is a fabulous real world lesson involving Bunnings and jelly tots and a few of my favourite things. And now I want to start singing again, and that's really not a good thing. So hi, welcome. What are we going to get done by the end? Well, the whole point of this is to know how to find the volume of a rectangular prism, and we'll discuss very quickly what a prism is, and how to find the volume of a cylinder. Now, as a recap, we already know that measurement is a topic. It's just awesome. It's fabulous. Thank you very much. In fact, it's one of those real world ones. You know how we always say, let's make maths more real world? Well, this is it. It's about measurement and all sorts of stuff. So basically, if we can find areas and volumes of things, then we can pretty much take over the world, like Pinky and the Brain. Have you got any idea who Pinky the Brain is? No? Well, that's them there. A little bit of my hero, Pinky and the Brain. But let's go back to the fact is, now what you can't see at the moment in time is my house is a wonderful grey colour. Now you might try and say grey, but it used to be yellow. Yes, the house I moved into, the gentleman beforehand decided to paint his whole house yellow, and it really was not a lot of fun. So, walking in here I said, okay, I need to paint the walls. So what I'm going to do is I'm going to go to Bunnings and I'm just going to buy so much paint, and I'll just hope and pray that it's the right amount for all of my walls. Well, actually, no, that's not what I did at all. Because what I did was I went, well, let's look at each room as a separate part. And if I imagine there is my room, here is a door to get into my room, and here is a window. Now, obviously, there's nothing outside my window, but because I'm not much of an artist. But what I thought was, well, if I knew how much area there was in all of the space that I need to paint grey, then hopefully I can go into Bunnings and someone will tell me how much paint I need. And actually it's true. In fact, I didn't even need anyone in Bunnings, because for example, if I knew my area of my walls was 25 square meters, pots of paint in Bunnings, and I should have brought one in from the garage, shucks, but pots of paint from Bunnings actually have on them how much of a square meterage each pot of paint will cover. So for example, if I found out that a pot of paint covered 10 square meters, I now know that I need 2.5 pots of paint. No, I know. Hold on a moment. That's not true. What I actually need is 3 pots of paint. Why do I need 3 pots of paint? Well, basically, I can't have 2.5 pots of paint. Can you imagine going into Bunnings and just picking up a pot and going, no, thank you. I don't want half of this, and pouring it on the floor? I'm fairly sure security would haul you out faster than you know what you were doing. So, being able to work out volumes and areas and all those type of things for all types of shapes is actually really, really important. Now, Christmas is coming. Well, it's not actually coming, depends when you're watching this, but I recorded this in September and it's almost close. In fact, Maya have up their Christmas decorations, which is weird. But basically, I used to get kids to, at Christmas in the UK, make little boxes, little nets of solids, little fabulous boxes they were, and then I used to take them home and fill them with chocolate. Now, if you're one of my students at the moment, don't get too excited, yeah? We're not making boxes and I'm not filling them with chocolate. I'm sorry, okay? Not this year. But I would also need to know how many chocolates would fill in one of those boxes. So I had to find the volume. And what actual shape is a box? Well, if I draw a quick one here, it is a cuboid. All right, now a specific one, if it's a box and they all have the same side length, is in fact a cube. And the great thing is we've already done the whole idea of finding volumes of shapes. If we had rectangles, we did this times this, or this times this, or this times this, and this times this. Now, if you don't know what I'm talking about at this moment in time, you think I've probably lost it. But it's in a previous video. Just go back and have a look. But the great thing about cubes or cuboids is the same process works. I do this times this times this. So do, as it goes. Now that came into the camera at you. Hopefully you're not wearing 3D glasses when you're watching this. But if I know a corner of my cube, I can find a volume. Now, the question is, what is a prism? We can talk about these prisms. Now, I don't actually live anywhere that sells Kazam crunches, but I have to say they look good. More sugar in one healthy snack. Now, sugar is bad. Don't take sugar. But obviously, this box is an example of a rectangular prism. And from a more mathematical point of view, here is a box there that is also a rectangular prism. Now, if we go back to my analogy that I've used many, many times before about the idea of a bread slicing machine, which I think is just like the most amazing thing to have. Can you imagine having one of those in your house? You wouldn't just put bread through it, would you? I mean, you'd put all sorts of stuff through it. I mean, I'd be forever slicing stuff up, but that's just a whole weird thing to say. But I need to be able to imagine if I put a piece of bread through a bread slicing machine, what happens? Yes, hopefully, if I put it in the right way, every slice comes out exactly the same shape. Yes, I know the crust is slightly shorter, stop being difficult. But the point of it is, a prism is a shape that if I put it in a bread cutting machine with all those very sharp, razor sharp knives, and pushed it through, being careful, health and safety, then I'd actually find out that each piece comes out exactly the same. So, when we have a cuboid or a cube or a rectangular prism, the volume is found very, very simply. And there's three ways of doing it. Now, the first one is this more generic one, which says that the volume is equal to base times length times the height. Well, at this moment, this is the base, this is my length, and this is my height. But depending on which way round I put the shape will change whether it's base times length times height, which is very much why I say to myself, choose a corner and look at the three sides that are joining that corner together. They are the three sides you need to measure. Why? Well, maths is a big fat trick. Big fat trick. And I could put 10 and 4 and 10 and 10 and 8 and 8 and 8 and what would that be? 4 and 4. Now my shape has so many measurements. And sometimes it becomes really confusing to know which ones to use. And that's why I say, if I was to choose one of those corners and just choose the three measurements that match it, then I'm always going to end up with a volume, which in that case would be 10 times 4 times 8. So 40 times 8, which is 816, which is 320. Now, what units do I have? I didn't put any units on my diagram, and we have to show units. Now, my advice to you is, if ever you don't know what the units is, you write the word units with a little floaty 3. Why the floaty 3? Because it's volume. Now, actually, moving on, while volume equals base times length times height is awesome, I tend to want to use a different formula. And this is probably a more important one, and it says volume equals area of cross-section times how far back it goes. And later on, I've written it again, but with the word depth. And again, depth is very dependent on which way around you have your shape. But I suppose the important thing is if I have a prism, and I'm going to deal with a cuboid at this moment in time because it's the easiest one for me to draw. Area of cross-section is basically saying find an area of a face. Now it's important to know that the face should be the face that is the same all the way through my object. If I slice it, it's going to be all the way same through my object. So for example, I could choose this as my cross-section. It's a face. This is a face. It's a face. Anyway. And here's my 10, and here's my 8 and my 4. So to find the volume, I can find the area of the cross-section. So if I was going to find the area of the shaded section now, I would have area equals 10 times 4. So that's my cross-section, which is 40, and we don't know what the units are, so I'm just going to write units squared. Having found the area of my cross-section, I now multiply it by how far back it goes. And again, back is very relative, but I know that it's going 8 units back. So I'm going to now say that my volume is equal to 40, which is the area of my cross-section, times by 8. Whoops, don't do it there, Mr. Smith, that's bad. Which gives me 8, 16, 320 units cubed again. Now, that's good because that's exactly what it was before. But this area of cross-section is actually really, really important. Really, really helpful. And actually, as we can see in a moment, I'm going to start talking about my favourite chocolate in the world, which is Toblerone. Yes, but again, if I had a cube, and how do I know this is a cube? Well, I'm just going to do these little lines everywhere that tells me that's a cube, which means I only need to do one measurement because I know all the rest are the same. So let's find the area of cross-section. All right, so the area, and I'm going to write little xs, which otherwise means extra small, but a whole new discussion, is equal to 3 times 3, which is 9. And now I can write centimeters squared. And I know that my volume is equal to 9, which is the area of the cross-section, times how far back it goes. And I know in that situation it goes back 3 centimeters, which is 27 centimeters cubed. You see how this works? Now this area of cross-section is really awesome in all sorts of stuff. Imagine I have a pond. And there's my pond. And I happen to know how deep my pond is. And this is going to be a really dodgy drawing, but actually, no, it's not too bad. All right, so here's my pond with little ripples on it from the wind. If I tell you the area of cross-section, so the area of cross-section is 100 square meters, which is a fairly large pond. And I know the depth of my pond was 1 meter. then I've got all the information I need. I don't have to worry about choosing corners of this times this times this. All I need to do now is say that volume is equal to the area, which is 100, times the depth, which is 1, which is 100, and in this case, meters cubed, because it's a volume. To see how this works? This area of cross-section is awesome. Now, we have to be very, very careful, because shapes like triangular prisms, you have to be careful to make sure you know which one is the face, all right? Which one is the cross-sectional face you're going to use. So if I draw my prism, doink, 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 doink. So there we go, there's my prism, my triangular prism. I have to make sure that when I put it into my bread slicing machine, it gives me the right shapes, that they're all the same. And so in this situation, this would be my face here. This triangle here would be my face. Now again, I might already know, because the question tells me that my area of cross-section is 8 centimeters squared, and it may tell me that my Toblerone box goes back 10 centimeters, and I have all of that information. But it doesn't matter. What if they didn't give me all of that information, but they told me that, for example, the height of this was 8 centimeters and the width of this was 4 centimeters, and it went back 12 centimeters? Well, again, because my face there is a triangle, we know the area of a triangle is that times that and halve it. So I would do area of cross-section is 8 times 4 and then halve it. So 8 times 4 is 8, 16, 24, 32, divided by 2 gives me 16 centimeters squared, which would tell me that my volume then would be 16 times 12, which is a very big number. Let's use my calculator. Okay, 16 times 12 equals 192. So 192. The last part of my lesson really deals with my other favorite sweet, and that is jelly tots. My nan, I love my nan. My nan is amazing, but at Christmas she sends over packets and packets, or tubes and tubes of these jelly tots. And if you don't know what the jelly tot is, you haven't lived. It is sugar, sugar, sugar. Sugar's bad, remember? Sugar is bad. But wow, sugar, it's fabulous. But the point of it is, that packet comes as a, this thing's called a cylinder. In fact, lots of things comes in cylinders. And cylinders are awesome, because if I actually turn my cylinder around, then what is the cross-section? What shape is the cross-section? Yep, I'm giving you the idea now. It's a circle. So when I draw these things, I tend to draw them mathematically like that. Why? Because this is the face I'm going to find my area of. How? Well, in the previous video and previous lessons, and probably from years ago, we are taught, or you are taught, that the area of a circle is equal to pi times the radius squared. And then all I would need to know is how far back that goes, the depth or the height or the length or whatever it is, to find the volume of my cylinder. And so, realistically speaking, my volume of my cylinder is given by pi r squared times, and in that formula there, d. Why? Because this here is the area of that circular face. And d is how far back the circle can be stretched, right? Now, cylinders are brilliant. Again, as I say here, exactly the same idea, right? The volume is the area of cross-section times the depth. But you notice my diagram seems to be a bit different. I just drew it that way. What's maths going to try and do? They're going to try and trick you. Can you see the circle? Do you know what it is yet? I can see the circle here. So there is my face. That coloured in section there is my cross-section that I'm going to try and find the area of. What shape is it? It's a circle. So I know that the area of the cross-section is going to be pi r squared. They just need to give me the radius of this shape. And they can give me the radius in all sorts of different ways. It might be 6 centimeters. And then they give me this height, say of 10 centimeters. And so I've got everything I need to do to help me find. So my volume is equal to the area of the cross-section, which is pi r squared, times my height in this situation. So pi times my radius is 6 squared times my height of 10. Loading up my calculator, clearing what was there before so that we don't have mistakes. He says clearing. So what do we have? We have pi, where are you? Pi times radius times 10, which gives me 1130.97 to 2 decimal places centimeters cubed. Sounds big, doesn't it? but numbers for volume actually do get quite big. Right, so as I say, always make sure that you know what the volume of each of your shapes is, be it a triangle, a square, or a circle. Yeah? And this, as I say here, is our final formula. Right, one more example. What should we have? There, and there. Let's say that we know the radius. Let's actually give this one the diameter. So the diameter is 8 centimeters, and the length back is 9.6 centimeters, because we can have decimals as well. We're trying to find the volume. So the volume is equal to my area of cross-section, which is pi r squared, area of a circle, times how far back it goes. In this case, we're going to say h, d, doesn't really matter. So pi times, now radius squared. Bearing in mind I said, I'm going to go as diameter. The diameter is from one side of the circle to the other. We want from the center to the edge as a radius. So if I know that from one side of the circle to the other is 8, then I know half of that will be 4, and that's my radius. So I'm going to do 4 squared times 9.6. Now I know what 4 squared is in my head, so I'm actually going to write that as 16. I'm going to load up my calculator, and I'm going to go pi, so clear it first. Got pi times 16 times 9.6 gives me 482.55. 482.55 centimeters cubed. And again, just so that you know, generally speaking in maths, we always round to 2 decimal places unless the question tells you otherwise. And if you don't know how to round to decimal places, I'm pretty sure I've got a video coming on it pretty soon. Now, what we can do forwards, ladies and gentlemen, we can do backwards, and I promise you I'm nearing the end of this video, but sometimes they'll give you the volume and ask you to find the radius, for example. So again, let's have a circle, cylinder, sorry, and I'm going to tell you the volume of this is 500 centimeters cubed. I'm giving you the volume. I'm going to tell you that it goes back a distance of 8.2 centimeters, and I want you to find the radius. Well, as I'm fond of saying in maths, and what do I mean by that? I mean, so formula, substitute, and then solve. So in this situation, always write the formula first. So I know the formula for a cylinder is pi r squared times h. Now substitute all the values they've given you. Volume I know is 500. Pi I know my calculator knows. Radius I don't know, so I'm trying to find it. And I know my height is 8.2. So now what I'm going to do is I'm going to divide each side, because I've got a times by 8.2. I'm going to divide each side by 8.2. So 500 divided by 8.2 is equal to pi times radius squared. So using my calculator, come on, calculator, load for me. So clear, 500 divided by 8.2 gives me 60.975. So 60.975 ... Now the reason I'm going to do those dots is because I'm going to say I'll round my last answer. I'm not going to round now because my calculator can remember all that. But I know that that's equal to pi times radius squared. I want to get rid of a times by pi. So I'm going to divide both sides by pi. So 60.975 ... divided by pi. Load up my calculator. Divide by pi. Hit enter and I get 19.409. So 19.409 ... is equal to r squared. And now I just need to get rid of this squared. Well, how do I get rid of a squared? I square root. Yes, I square root. So I'm now going to square root 19.409 ... And again, I'm going to leave those dots in because it's now that I'm going to round. I've got my final answer. So load up my calculator. And I'm going to hit the square root button. And out comes 4.41 to 2 decimal places. So 4.41 to 2 decimal places. Have I forgotten anything? I should go. I've forgotten my units. So that it was given in centimeters. And there are my centimeters with my final answer. Now that's it really. What have we done? We've looked at how to find the volumes of rectangular prisms by doing this times this times this. We looked at the general case of prisms, even triangular prisms, and then cylinders. We've done some examples of forwards and backwards. Now I hope you've enjoyed this video. That's it from me. Now if you've liked it, why not subscribe by hitting that circle there for me, or watch another video on the other side. It's been really good seeing you today. Thank you so much for dropping by. I look forward to seeing you again.